Video, we are going to go through the process of analyzing a rational function. So we're going to go through the steps. First step will be factoring the numerator and the denominator. Second step includes finding the domain. This is where we have to exclude values that don't work in the function. Third step will be to cancel all the common factors. We're going to save those, so we'll use them when we figure out wholes. We will find the zeros of the function. Those are coming from the numerator. We have the vertical asymptotes. Those come from the denominator. Then we will analyze horizontal or oblique asymptotes. We do that by dividing the function. And then the last step will be to find any wholes that we might have. So we're going to go through the process through given a function. Let me erase this. And so we're going to start with our function r of x. Now, it's already factored for us. So a lot of times you're going to have to factor it yourself, but it's just easier. We're going to start with it already factored. My second step is determining the domain. So to determine the domain, I'm going to take any of the values that are going to make the denominator equal to 0. In other words, I'm looking for the zeros of the denominator. So that would be the 5, -1, -1 again, and 3. So my domain is going to be the set of all x such that x cannot be equal to, and it's best if you can put them in order, so -1, 3, or 5. And that's my domain. After figuring out my domain, oops, sorry about that, I'm going to go through and I'm going to cancel any common factors. So if we look at this, we've got a common factor, x minus 3, that's going to go, and x plus 1 is going to go. This leaves my function r of x as 2x minus 1 times x squared plus 2 over x minus 5 times x plus 1. And that's my new function. All of the other things that we analyze are going to be coming from this reduced fraction. I do need to save my factors x minus 3, so a 0 of 3, and x plus 1, a 0 of -1. We'll analyze that later to determine whether either of those represent a whole in the function. All right, my next step is, hold on. There we go. So here's my reduced function now. I've canceled everything. Now it's time to look for the zeros. Zeros come from the numerator. So if a 0 in the numerator, that will make the entire function equal to 0, which is the definition of a 0. So I'm looking for the zeros given the factor 2x minus 1. What will make that 0? X squared plus 2. What will make that 0? So x will be equal to 1/2. And we've got x squared equals -2, or x will equal plus or minus I square root 2. So we have a 0 here and a 0 here. Now, in addition to the zeros, we can look at the x-intercepts. An x-intercept here is what we get when y is equal to 0. But remember that they have to be real. So we've got an x-intercept at 1/2, 0. This one's not real, so we can ignore it when we talk about the intercepts. So x-intercept of 1/2, 0, and zeros of the function at 1/2 and plus or minus I square root 2. We can also do y-intercept at this point. A y-intercept at this point is what we get when we set the x equal to 0. So if x is equal to 0, my y is going to be equal to 2 times 0 minus 1 times 0 squared plus 2 over 0 minus 5 times 0 plus 1. Or what we get is -1 times 2 over -5, times 1. So we get -2 over -5, or positive 2/5. So y-intercept, 0, 2/5. Next step in analyzing the function is to determine the vertical asymptotes. Vertical asymptotes come from the denominator. Remember, a vertical asymptote is the line the graph approaches So it doesn't actually cross this, but we can see that we're going to have a vertical asymptote at x equals, remember the x equals is important. This indicates a vertical line, and that's what the asymptote is. It's a line. So x is equal to 5, and we're also going to have a vertical asymptote at x is equal to -1. My next step in analyzing this function is to determine the horizontal or the oblique asymptote. And this is a horizontal or oblique asymptote is the horizontal or oblique, which just means it's not horizontal, line that the graph approaches as your x approaches positive or negative infinity. As x approaches positive or negative infinity. So when we divide, we are going to multiply these out. So what we get is our 2x cubed minus x squared plus 4x minus 2 divided by x squared minus 4x minus 5. So when we do this division, we're going to do it long ways. So we get 2x cubed minus x squared plus 4x minus 2 divided by, sorry, I'm kind of running out of room, x squared minus 4x minus 5. So we take our first step, 2x cubed divided by x squared, and we get a 2. Multiplying that through, I'm sorry, that's a 2x. Multiplying it through, we get 2x cubed minus 8x squared minus 10x. We subtract. So the first column goes away. We've got -x minus -8x squared, which gives me 7x squared. 4x minus -10x gives me 14x. We bring down that -2, and then we repeat it all again. So 7x squared divided by x squared gives me, sorry about that, 7. So we get 2x plus 7. Multiplying it through, so I'm going to do it horizontally here. So we get 7x x squared minus 28x minus 35. And we subtract this from here. So 7x squared minus 7x squared is 0. 14x minus a negative 28x gives me 35, 42x, and negative 2 minus negative 35 gives me 37. Now this is remainder. We can't divide that x squared into it. So we end up with plus my 42x plus 37 over x squared minus 4x minus 5. Now remember my definition of a horizontal asymptote. This is what happens when x approaches positive infinity. So if we think about this, we've got an x over an x squared basically. So if we're talking about infinity, infinity divided by infinity squared, we've got a small number in the numerator, a large number in the denominator. So what happens as x approaches 0 is that this fraction, as x approaches infinity, this fraction approaches 0. So basically the remainder doesn't matter. So what we get is an oblique asymptote at y is equal to 2x plus 7. We're going to look at horizontal and oblique asymptotes in more detail in a second video. But at this point, we can go forward and finish up by looking at the holes. So now a hole comes from my saved factors. So I've got these guys that were canceled and saved. Okay, so x equals -1, and we've got x is equal to 3. Now, if you remember, x equals -1 was a vertical asymptote. We cannot have a hole at the same place we have a vertical asymptote. So the vertical asymptote eats the holes. So we do not have a hole here at x equals -1 because it is a vertical asymptote. On the other hand, x is equal to 3 does not have a matching vertical asymptote. So what we have is a hole at x is equal to 3. Now we can find the exact point of that hole by plugging it in. So I can figure out r of 3 is equal to 2x minus 1, which is 6 minus 1, or 5, times 9 plus 2 gives me 11 over 3 minus 5 would be -2 times 3 plus 1, or 4. So we're going to have a hole at the coordinate 3, -55 over 8. And that is it for this one. That's the analysis. Again, what we found was we found zeros. Hold on. We found my domain. We canceled our factors then and saved those. After that, we were able to find the zeros. Sorry, let's try that one again. We found the zeros of the function from the numerator. We were able to find the x-intercepts and y-intercepts. We've got vertical asymptotes from the denominator. We've got a horizontal or oblique asymptote by dividing. And finally, we were able to find the holes coming from those saved factors. Again, look out for the asymptote video. We're going to go more in depth on horizontal and oblique.